In this lesson, you will gain experience in developing an XML markup language for several types of documents. You will also learn how to prepare document type definition for the XML code you develop and how to test your documents for correct structure and syntax. Before you can begin developing XML applications, you need to understand the kinds of markup that are allowable with XML. The following sections introduce you to the 5 major types of XML markup. XML tags are more properly called elements. Most XML elements occur as pairs of tags, a start tag and an end tag. The start tag begins with a less than sign and ends with a greater than sign. Between these characters, there is a keyword that indicates the meaning of the text that the element marks up. The tag shown here is an example of an opening tag for an XML abstract element. The corresponding end tag is constructed exactly the same as the start tag, except for a forward slash occurring between the less than sign and the first character of the keyword. The text that occurs between the start and the end tags is what the element is describing. Thus, you might expect to see the abstract element used as shown here. Elements that comprise of start and end tags are sometimes referred to as container elements because they designate the meaning of the text contained between the tags. Not all XML elements are containers, however. XML elements comprising of only one tag are called empty elements. Empty XML elements are distinguished from start tags of container XML elements by including a forward slash before the greater than sign that ends the empty element. Look at this example. Here you have an empty element that specifies a line break in the document. The forward slash in the element is an indicator to an XML parser that it should not look for a corresponding end tag. You can treat an empty element as a container element by immediately following the element's start tag with an end tag. Thus, you could use the XML code shown here instead of the single line break element. In addition to their keywords, some XML elements make use of attributes to modify the element's meaning. Attributes are set equal to values that are offset by quotation marks. The XML element shown here makes use of an attribute. It is important to note that the quotation marks around the value of the attribute are not optional. If you do not have quoted attribute values, your document will not be syntactically correct. If you've used code like &LT semicolon or &NBSP semicolon in your HTML documents, you've made use of HTML entities. HTML uses entities to be able to render characters like less than or greater than, which are reserved for construction of tags. XML entities behave in the same way. They begin with an ampersand and end with a semicolon. Between these characters is a keyword that specifies which character should be substituted in place of the entity. The entities you know from HTML are already part of the XML standard. In addition, you can define your own entities as you need them. XML borrows the constructs shown here from SGML for creating comments. Any text found between these character sequences is considered to be a comment. You can place anything you'd like between these two sequences, except for the double hyphen construct The double hyphen is reserved for defining the comment. You can use processing instructions or PIs to pass information from an XML document to an application that processes the document. They are analogous to the parameter tag you might use in an HTML document to pass a parameter name and value to a Java applet. XML PIs have the format shown here. The name of the PI is also sometimes called the PI target. You are free to call a target whatever you'd like, but you may not begin a target with the characters XML, as the W3C has reserved targets starting with these characters for standardization purposes. The data portion of the PI can be set to anything that the processing program will recognize. Thus, an example PI that passes the value of the square root of 2 might look like this. Occasionally, it becomes necessary to pass information to a processing application that contains an XML reserved word or character. When this happens, you can define an ignored section of the XML document that will be ignored by a parser while still being passed to a processing application. One case where it becomes necessary to use ignored sections is when you're passing mathematical information. Mathematical expressions often contain greater than or less than signs. These characters are reserved for creating start and end tags. So, to pass an expression that uses one of these characters, you have to use an ignored section. All ignored sections start with and end with the character sequences shown here. You can put whatever text you want between these character sequences except for this construct. Whatever is placed between them will be passed to a processing application and be ignored by an XML parser. Now that you are aware of the types of XML markup, you are ready to begin creating your own markup languages with XML. This section introduces you to the activity of developing a set of XML elements appropriate to a given class of document. Because there is such a wide variety of documents that you can mark up with an XML-based language, there are no real hard and fast rules for choosing a set of elements. However, there are some basic principles you can use to guide you. Identify the overarching structure of the document. This is helpful in choosing what is called a root element for the document. A root element is a container element that contains the rest of the XML markup in the document. The root element cannot be contained within another element in the document. Identify and list out the major components and subsections of the document. Each of these is typically a good candidate for an element in the document. Think about the different variations possible with each element. This helps you to identify possible attributes for the elements. Always keep a hierarchy in mind. This is important to be aware of which elements can be contained in others and which cannot. A DTD is simply a text file that summarizes the syntax of an XML-based language. DTDs are used to specify elements, their attributes, which elements can be contained inside other elements, and any entities that are needed for the document. All of the rules governing the language have to be specified in a very precise way, however. Now, let us look at the advantages of having a DTD. DTDs tell XML processing programs the default values of all attributes in the document. DTDs enable an XML processing program to determine an element's content model. An element has a mixed content model if it can contain text and other elements. If an element can only contain other elements, it is said to have an element content model. An element's content model is important because it tells the processing program how to deal with extra white space in the document. Extra white space is ignored in an element content model and is taken to be significant in a mixed content model. Additionally, DTDs allow you to test your documents for a property called validity. You have spent a lot of time learning how to prepare a DTD for an XML-based language, so it might surprise you to learn that a DTD is not absolutely necessary. A DTD certainly helps an XML parser to process a document, but as long as the document adheres to the following rules, a parser should be able to successfully process it. The document contains one or more elements, including a single root element. The document conforms to the basic grammar put forth in the XML specification published by the W3C. All container elements are properly nested. All attribute values are contained in quotation marks. Only one of the following reserved entities should be used: ampersand LT semicolon, ampersand GT semicolon, ampersand AMP semicolon, and ampersand APOS semicolon. If a document satisfied all of these rules, it is said to be well-formed. An XML parser should be able to construct a document tree for a well-formed document, but it would not be able to check to see if the elements are used properly without a DTD. Thus, a well-formed document might have syntax errors, but is still sufficiently structured to allow a document tree to be built. An important thing to note is that if a document is not well-formed, it cannot be considered XML. A document that is not well-formed will be rejected by any XML parser. This may seem harsh, but it provides an assurance that bad XML code will not break a processing application in the way that extended HTML tags broke some browsers. This, in turn, forces document authors to develop good coding habits when they prepare their documents. If a document is well-formed and satisfies the rules put forward in a DTD, then the document is said to be valid. Validity is a stronger condition than well-formedness because it ensures that there are no syntax errors in the document. Having a valid document is always preferable to having a well-formed document because the valid documents accompanying DTD makes the document more widely publishable than if it were just well-formed. This is because the information in the DTD enables any processing program to parse and render the document exactly as the document author intended.